Hi everybody, welcome back to the bench. Well, I really didn't have a lot of time in the last 2 weeks to do much work at the bench, and it's Saturday morning right now and I had some time, so I decided I'd actually get some much needed chores done around the house and around the bench. And one of the things I wanted to do was rearrange a few things, and it got me to thinking when I did it that maybe I could share with all of you a few things on the bench, some unique test equipment. It's a new piece of equipment that I just acquired, and I was going through some of my gadgets, and I have my little gadget basket with some things that I use a lot on some of these projects, but I don't necessarily show them in videos. And what we'll do is we'll go over some of these things, and if any of them look interesting to you or are something that maybe you think you could use or would like be interested in building yourself, maybe we can do a separate video on one of those. So you could let me know down in the comments section. And a lot of these things I will have schematics and so forth posted up on Patreon. I do have some of this, not all of it, but trying to get some of it cataloged and put up there. But at least we can get something up here. So this is truly going to be a random video, and I really don't know where I'm going to go with it or anything like that. And I don't even know if it's anything you'd be interested in watching. You know, it's not some sort of teaching video that you'll get disappointed and say, hey, I thought you were going to teach me how to do this and you're talking, you know, whatever. That's what you're getting with me. So without any further ado, let's move over to the bench here and take a look at some of the things here. And I am going to be doing a video on a piece of test equipment that I'm going to be restoring. I just found a really nice example of one online and I purchased it, and we'll probably do a video on that sometime in the future. All right, let's take a look. Well, the first thing I did was I cleaned off the top of this spectrum analyzer, and I placed my Fisher 500 up here just to be able to listen to it for some background music when I'm working down here. This is probably one of the most sensitive and selective tuners that I have. Even though it's vacuum tubes and it's very old, it's unbelievable how this thing performs, and it has that really warm, smooth vacuum tube sound. And yeah, sign of the times, even though it's only the first week in November. Soon it will be Christmas. Yeah, they're playing Christmas music already. The holiday season. I guess some people just can't wait. My neighbor across the street already has their decorations up and everything, but hey, it's good to look forward to things, you know. Anything that brings happiness, you know. And so who am I to judge? I enjoy it too, all right? Full disclosure. Anyway, tuner is up there. I did a video series. I did 2 of these. One of them was for myself, and the other one another owner has, and it's in his collection. The other one had an actual cover on top of it, if you remember. This one did not have the case with it. So it's perfect for down here, and I really love it. It's a lot of fun. All right, let's move over to the bench. As you can see, the Tektronix TDS 3032 has been removed from the bench, which, believe it or not, that's my favorite scope. But I kind of wanted to move things around for right now. Don't worry, it will eventually be back on the bench. You know me, I kind of rotate things around. And I moved the TDS 5054 into the position where the 3032 used to be. And I took some time and went through the software, and I wrote the little math expression to be able to calculate the wattage for the 8 ohm dummy load. So this can take over that position as well. And it's a 500 megahertz scope instead of a 300 megahertz. It's a 5 gigahertz sample per second sample rate instead of the 2.5 gigasamples. So it's a little bit better, but it is old technology, and the newer scopes by Tektronix actually are a lot better. This one's running Windows and so forth, but it's still a great scope. It works really well, and I think, you know, with the other things on the bench, this is going to be a great addition. I'm going to start using it. Next to that, I have an electronic circuit breaker. And I know this doesn't look like the one that you see me use all the time that was in the video where I actually built an electronic circuit breaker. And it was based on the one from Glasslinger's YouTube channel, Ron Soyland, who to me is brilliant. When you kind of read between the lines, some of the things he says and does, you can see that he has many years of experience. And he is a wealth of knowledge. If I could only sit down and interview him, I'm sure you're all saying that, any of you who have watched his channel. He is very intelligent. And I really appreciate him sharing the idea for this. And this is similar to his design with a few changes that you can see in my video. And one of the big differences between this one and the one in my 2 videos I did on this is that the original one that I did, instead of using a relay, it used an SCR pack, which works really well. And I still have it. It's down here under the bench. I don't know if I can show it to you. See it? Right down there. But this one, I made a few changes. Number one, I built a variac into it so we can have adjustable voltage. The reason I did that was not so I could bring something up slowly on a variac, even though you could do it with this, but also because if there's some line voltage drop from my isolation transformer and I want a very accurate line voltage, or let's say I want to simulate line voltage from an earlier era. A lot of the vacuum tube gear from the 1940s and 50s, it ran on 110 or 117 volts, and today's power runs up to 120, 125 volts, at least here in the United States. So I wanted to be able to replicate those voltages, so that variac helps us to do that. I also made it a little neater, just the layout, put it in a metal case and so forth. But I made one major change, and I showed you that SCR pack that I had in the original one, and I still do. But because of the variac, I actually found out that when I adjusted the variac to prior to about 50%, it would actually cause the SCRs to misfire. And it doesn't do this on my other one. But to have it wired the way I wanted it here, it wasn't super stable like that. So what I did was I did go back. So here's the original design that we had, and you can see the how this works. And then all that I did was I took this whole part, well, I actually left this part soldered on a board. I just unplugged the chip. I disconnected this, and in place I just did this. It was a very simple modification. All I had to do was wire the switch where this line would be, right in here. And I put 180K, should be the 1.8K. Remove the 1.8K resistor, which was that one down here. And I replaced it with the relay coil. So essentially all that's happening is when the SCR fires, instead of grounding out this circuit and making it stop working, it just activates this relay coil. And I used a relay, let's see if I have one, that looks like this. It's one of these. And I found that this particular relay can fire in like 8 milliseconds, which is the same amount of time, believe it or not, that the SCR can extinguish itself if it does self-extinction. So I get the same reaction time. Now the only downside is, in order for it to move that fast, I have to use the normally closed contacts. You can see normally closed. So activating the relay opens the contacts. Now, the bad thing about that is if the relay fails, the circuit will fail closed, which is why it's important to have a fuse or some secondary protection in there. Now, normally when I have something on the bench, it either has a fuse in it itself, or I'm using the current limiting bulbs on the bench or something like that. But I also have, for the last ditch effort here, I have an 8 amp breaker that will pop. So again, it's just something you have to remember when you use a relay for this electronic circuit breaker versus the SCRs. The SCRs will fail closed. As soon as you hit the zero crossing, they'll extinguish themselves and turn off unless they have a constant drive signal in this. Go back and watch my videos on it if you're interested. But anyway, I put it up on the bench. You will see it probably whenever I work on vacuum tube radios, especially like the old Hallicrafters that I do and things like that. I like to use this, especially vacuum tube guitar amplifiers. Whenever there's a vacuum tube involved that can kind of run away and go into a high current situation, you know how tubes will red plate and so forth, this is perfect for that because you can set it to trip above the amplifier's normal operating idle current. So you can turn an amplifier on, let it sit there and idle, and if the tube starts to run away and red plate, this will trip and it'll prevent the amp from being damaged. So it's a cool little thing to have. Is it really necessary for the bench? No, but I like it because it allows you to put the full power on to a device, unlike a dim bulb tester, so you get the full voltage and so forth, while still having a lot of protection for the circuit. So if something goes wrong or shorts out, say a capacitor fails on an old amp or an old radio that you're powering up, this will shut off. Now we do have another new addition to the bench, and it's this meter. And I didn't even know that this meter existed, nor did I really know that Amprobe was still making multimeters. I just don't look at stuff like that very often, but I kind of happened across this one, and I looked at it, and I said, wow, the features on this thing were great. This thing is still being manufactured. It's still up for, you can buy it. And it seems like when you go on all of the normal haunts, you know, like eBay and Amazon or wherever else, this meter seems to be somewhere in the $150 to $200 range. And yes, the price varies that much on these. The reason I bought this one is there was a seller on eBay that had this advertised as new open box. And I can tell the package had been opened, but it looks like it had never been tried out or used or anything. And it was perfectly put back into the package and sealed up, and I ended up getting it for $80, which I thought was a very good deal. Once I started looking at this meter, though, I was really amazed at how many features it has and how well it works. It's a great meter for the bench, for the price. Even at full price, it's similar or less money than something like a Fluke meter or something, or one of the Keysight meters, and yet it's, in my opinion, every bit as good. Couple things. Number one, when you go into ohms mode, look how quickly the meter reacts. I mean, it's instant. Most meters are much slower than that. It's very fast. As a matter of fact, let's see, I have a Fluke 87 here. Let's see how it compares. I'm sure it's going to be pretty close because these are pretty good meters. Let's plug in. These are the original probes that come with the 87. And this is a Series 5. So that's one of the newer versions of the 87. Let's just see what it does. It's pretty quick. But not as quick, I don't think. I mean, like right now. So, anyway, that's not a big deal to me, but I do like that they can react quickly when you're working on something where the voltage is changing on you. It's nice to be able to see it track quickly. Another thing I liked about it, it has a logic mode, and you can do TTL and you can do high and low and so forth. It has the normal diode check. It has the continuity. It actually will read dBm. So it can read dB with respect to a milliamp. And I think that's pretty cool. And it's based on a 50 ohm load. Okay. Now, of course, with all the noise, it's going to false trigger, but that's a pretty cool feature. It has capacitance, and it actually measures inductance. Very few of these multimeters I know of have that. So I was really impressed with this. It has a microamp mode, milliamp, and then up to 10 amps, just like most other meters. And I don't know. I mean, it's a category 3 at 600 volts, which is very good. It's true RMS. And if I recall correctly, the true RMS is good up to 20 megahertz. So not only is it true RMS, but when it's measuring AC, it's accurate up to 20 megahertz. And so is the frequency counter. So it's really an all-inclusive meter, and it's very well built for the price. So anyway, that's just my personal opinion of it so far since I've gotten it. And I think you're going to be seeing more of this on the bench. Okay, last but not least, we're going to go over some things that I use on my bench from time to time, but I really don't talk about very much. And this is just a box that collects things that I've had to use in the past or had to make. So I'll go over them, and if there's any of these that you're interested in, give me a comment and maybe we'll do a video on it. I'm just going to kind of randomly pull things out of here and we'll look at them. So for instance, here is a matching pad, and you've all seen me use the Sencor SG165, I think it is, which is the AM, FM, and multiplex signal generator. It's the predecessor to the SG80 that you see me use all the time. And for some reason, every time you buy one of those SG165s online, it never has the probes, especially the matching probe. So this is one of those that I made up based on the schematic. You can just connect a BNC connector from here to the signal generator, and then this provides the high impedance and the where is it? There, the 300 ohm and the 75 ohm matching pad, because it's got a 75 ohm output on the signal generator itself. Let's see what's next. This is a little thing I purchased on eBay, and it is a wideband amplifier, and it adds plus 30 dB of gain. And you can see it's good from 0.01 up to, what did it say, 2000 or 2 gigahertz. And why do you think I might need something like this? Well, the reason you may use these, they're very inexpensive. They run on a regular 9-volt battery, and they just have a signal input and a signal output. And what you can do is, for instance, let's say you're looking at a very small signal that's very low amplitude and high frequency. So for instance, in a radio circuit, somewhere in the oscillator section or something. A lot of times, if you hook your frequency counter directly to this, or your oscilloscope directly to the signal's not strong enough for your meter or your scope or whatever it is to pick the signal up. And if you direct connect a probe in a way that you can pick up a strong enough signal, it'll throw off the oscillator. So you have to very loosely couple the signal. What this will do is this will boost the signal just enough that you can actually see it on your oscilloscope or on your frequency counter, for instance. Now, with a frequency counter, you don't really care about the amplitude as long as it's high enough for the frequency counter to trigger off of it. With an oscilloscope, if you're worried about signal strength, that might be a different story because of impedance matching, but you do know that this gives you a 30 dB gain across that frequency range. So it does give you a little bit of accuracy, but I wouldn't trust it 100% because of the coupling that you're using. But anyway, it's a neat little gadget. They're only a couple of dollars online, and you know, that's why I have that. You've seen this before, and what this does is you can connect a stereo signal in and get a mono signal out. Now, you might say to yourself, well, heck, Tony, I've seen people just take a couple of 1K or 470 ohm resistors and just tie them together in one end, and then the other end goes to 2 RCA jacks. And you certainly can do that, but in some instances, you want to have a higher impedance, or you want to have a little bit of a buffer in between the signal generator and the device that you're testing. And that's what this does. This is a buffer, and it also correctly combines the right and left channel into a true mono output signal. And there's a little gain adjustment on the end. And it runs off of a split power supply. And there is a way you could do it with a single power supply, single rail. But I did it with 2 9-volt batteries. And running it that way, this thing can run a long, long time off of 2 9-volt batteries. As a matter of fact, I accidentally left the thing turned on overnight on my bench, and it sat for probably 30 hours. And when I came down, it still worked perfectly, and the batteries were still good. So I just use as an op amp, and I can't remember. It's like a NE 5532 or something like that. I don't know. But we'll look at it one day if you're interested in it. May not be interesting to you, but there we go. These are little constant current sources, and here's one that I kind of knocked together when I needed it at one point in time. And all this does is this will produce a very consistent 2 milliamp current source. So regardless of the voltage, it will always maintain about 2 or 3 milliamps, depending on the resistors that you use in there. Now, the problem with this circuit is these LEDs can give you a very constant voltage drop and so forth, but as the temperature changes on them as they heat up, they drift, more so than just a diode would. So this wasn't the greatest design in the world, but it does work. And the nice thing about it is with these transistors that I'm using, which is a MJE350 and an MJE340, you can put up to 300 volts on this. So actually, or 350 volts, I think. So so even with like a vacuum tube circuit, if you're looking at a constant current source, you know, for like a voltage amplifier stage or something, and you want to experiment with that, this is a neat little gadget. And then later on, I designed a little circuit board that lets you swap out components and things. It's a little more professional looking, and that's what these are. And this one even has, I have the 2 transistors thermally coupled, and this one holds really well. I'm using diodes instead of an LED, and this thing will hold rock solid all day long, whatever you program it for, depending on the resistors. But that's what these are. This, okay, this is a load simulator. What do I mean by that? Well, all 3 of these are tied together, and all 3 of these are tied together. So it's left and right channel. Of course, they're independent of one another this way. And this allows me to connect it to an oscilloscope with a high impedance input. And this allows me to connect it straight through to like an amplifier or something, if you're coming from a signal generator or from a signal source of some sort, an MP3 player, whatever. But more importantly, if you want to measure something on your scope, for instance, with a certain load on it, to simulate the type of amplifier you're going to be connecting it to, that's what this does. And I have 3 different resistances in here. I have, first of all, no load at all. a 600 ohm load. So like if you want to calibrate a VU meter, VU stands for volume unit, or virtually useless, as some people call it, but it's referenced to a 600 ohm input impedance. I also have a 47K because a lot of transistor amps have like a 50K or so input impedance, and a 100K, which would kind of represent a higher impedance. So that's what that is, and you can change the different kinds of resistors in here. It's a very simple thing. It's just a little switch, rotary switch with some jacks. So if you need to have, you're checking amplitudes or setting amplitudes and you want it to be very accurate, this kind of helps you do that. Here's another one of those matching pads. It's the same as this one, but it's the first one that I built, and it's a lot bigger and bulkier, but it's the same idea. This is is an isolation module, and it's for my spectrum analyzer, and all this does is it just ensures that if you get spectrum analyzers are very sensitive, and they don't like very high signal levels at the input. And so if you're working on tube gear, even though you're pretty sure that it's a safe level, you want to use something like this. Okay, so this will block the presence of DC, a couple things like that, and that's what this is used for. This is a, 60 Hertz twin T notch filter. Okay, so this is a notch filter. And what is a notch filter? It's a thing that what it allows you to do is you can cancel out or filter out a certain frequency or frequency range. So anything below that frequency or above that frequency can pass right through this. But anything at this frequency gets attenuated. So in this case, it's around 60 Hertz. I can show you what that looks like here. We'll do it real quick. Okay, I hope that's not too flickery for you. But as you can see, I have a 1 kilohertz signal on there, and I just have the signal generator coming into this side, and the scope is connected to this side, and if I pan out you might be able to see it. So you can see this, the wire coming from the signal generator and the wire going to the scope, and here's our notch filter. And if we zoom back in, so what happens is at 1 kilohertz we're getting our 2 volts peak to peak. All right, so there's 2 volts positive and 2 volts negative. However, if I go down to 60 Hertz, so go 60 Hertz, it's all gone. If I go to 50 Hertz, it starts to come back. And you can see as I go, I'm down to 10 Hertz. And you can see it's attenuated a little bit, but it's there now. Back up to 60, and there's nothing. As I go up 70, 80, 90, 100, and then it slowly starts, by the time you're up to about 300 Hertz, and now I'm at 500 Hertz, you can see we just about have our full 2 volts peak to peak. So that's a notch filter. Now why would you want to do that? And of course the roll off is not real steep, okay? But that's okay. The reason you would have this is in some instances when you're doing a test of intermodulation distortion, like the old tube gear where you did the two-tone 60 Hertz and 7 kilohertz. Sometimes it's difficult to view all of the harmonics and so forth because the amplitude of that 60 Hertz signal is so high. So by filtering out the 60 Hertz signal, you can still see all of the harmonics without having the 60 Hertz signal swamp everything out. And that's one reason you would use a notch filter. The other thing is if there's something that has 60 Hertz hum, because in the United States mains frequency is 60 hertz, you can remove any influence of your AC mains from an audio circuit as well. I've never really used it for that, but I've heard of people trying that before. Anyway, that's what this is. So I just realized in that last clip I did not have the microphone attached, so I will probably have to crank the amplitude when I edit this video, so it's going to have a lot of background noise. I apologize for that, but microphone is back on now. This is a bore camera, and you plug it into the USB of your computer, and this end is just a little tiny camera, and I believe this is a 1080p camera, little micro camera, and it has, let's see, somewhere, there we go, it has some different little mirrors and little lenses that you can put on the end of it, and this is really good. I've used this, for instance, on the really complicated, like the Hallicrafters SX42s and so forth, where you cannot see around all the circuits. If you're just looking to see if something's connected properly or if there's a bad switch contact, it's really hard. This is really nice because you can kind of get it in there and look and see using it. And I've used it for that before. It's kind of a handy thing to have. Again, you can get these online. They're not very expensive. Just look up endoscope camera or bore camera or anything like that, and you can get these, and you'll see they're not very expensive. What's this? Oh, this is a RF demodulator adapter that I built. This is really old. I made this a good while ago because I didn't have, at one point in time, I did not have a demodulator probe. What is a demodulator probe, you might ask? Well, all it is it's an oscilloscope probe that has a 1N34A or something similar to that, a germanium detector diode built into it. And what it does is it demodulates the RF from a signal so that you can monitor the modulation, so you don't without seeing the carrier. So sometimes you use that in television work, and sometimes you use that in old radio work. This just allowed me to use a normal probe and connect it to the scope, and it kind of makes it work just like a demodulator. It works really well. Again, some of the signal tracers and things that you see out there actually have that already built into them, where it says RF and audio. That's the difference. One of them has this circuit in it, the other input does not. Here is another amplifier, and this is a low noise amplifier, and it operates anywhere from 5 to 12 volts, same range, DC to 2 gigahertz, and instead of a 30 dB gain, it's 32 dB. It's just a little nicer one. You can see it's shielded on the back. Same purpose though as that other one that I showed you. Wherever it is here, this one right here, right there. This is just a USB battery stick, I think, for that bore scope. Oh, and this has Wi-Fi on it. That's right. So you can charge this up. There's a battery inside here, and there's a little Wi-Fi adapter, and you can connect this. It came with this, now that I remember. I never use this. I just use this directly plugged into my computer, but you can plug it into this, and then this will actually use Wi-Fi connectivity, and you can download a little app on your smartphone to be able to view the video on your smartphone through Wi-Fi, so you don't have to have a physical connection. That's what that is. Here is a detector probe, and again, this is for the SG165, the Sencor, and this is another type of probe that came with it, and this is if you're checking the detector section of an FM tuner, and this is for, like, if you wanted to sweep the detector set or the IF section of an FM tuner or so forth, or television. It'll work for that as well. But that's what this is. And I just, again, none of them ever come with these, so I had to make one. I think I have another one of these. It's a little neater version as well, someplace, who knows where. And I also have the original ones that came with the SG80, and let me show you those. And you could see here's the couple of them, and then there's the other one right here, and this is the detector probe, what it should look like. So that's one of them, and then this is the one of them's a direct probe, and one of them is a AMRF test lead. But those homemade ones simulate these official factory made ones, that's all. All right, miscellaneous wires in here. Let's see. Oh, here's an RF sampler. So you can connect, for instance, a transmitter to this side, an antenna to this side, or a load, and then this has a loosely coupled coupling it's like non-invasively connected, and you can get a sample output from here onto your spectrum analyzer or your oscilloscope. These are very easy to make. You can make your own, but this one is just a little better made one, and it works really well. This is a low frequency converter. What is this? Well, if you notice up here, you've seen this on my channel before, and I've used it. This is an audio frequency spectrum analyzer. It's a slow scan analyzer, so meaning the sweep is really slow. But it can sweep audio level frequencies. And so if you want to look for distortion products, you know, for instance, like harmonics and so forth, and you've seen me do that with this, that's what this is for. But with a normal spectrum analyzer like this MDO here, or with an actual spectrum analyzer, you can't look at anything usually lower than like 9 kilohertz, or, you know, sometimes higher than that. And a normal spectrum analyzer is just not very accurate at that range, nor can it take the higher input levels that you might be getting from speaker terminals or so forth. So it makes it very difficult to use a traditional spectrum analyzer. Now, this GW Instech up here can actually, since it's not a real spectrum analyzer, it's kind of a software one. It uses the oscilloscope circuitry, and then it does some math tricks and so forth to, and it's not FFT, but I mean, it actually will show you a poor man's spectrum analyzer, let's call it. But it will go down to audio frequency. Most of them will not. So what this does is it takes whatever low frequency you put in here, and it'll go all the way down to almost to DC, and it will convert it to, it will add 10 megahertz to whatever it is that you put into it. So and you can even use a reference, like a rubidium reference, or a crystal reference, or even one of the GPS disciplined oscillators like what I have, and feed that in to get it super accurate. And then, for instance, if you're looking at audio frequency, let's say you want to look at a 1 kilohertz sine wave, it will be 10 megahertz plus 1 kilohertz, so 10.01 kilohertz, or 10.01 megahertz will come out of here. That's all this does. So it's just an adapter box, and I bought this online, and I tried it once, and it seemed to work okay, but it was a little bit fussy with my spectrum analyzer, so I'm going to have to play with it a little bit more. But that's what this does. One of these days we'll try it out a little more seriously. This is something you've all seen when I did the video on how to connect a 50 ohm, 50 ohm output to a non-50 ohm load, and we talked about impedance matching. So what this does is this lets you put your signal generator into here, because if you notice, for instance, the HP 8657, okay, the output is relative to a 50 ohm impedance or a 50 ohm load. But most audio gear, like a receiver, will either have a 75 or a 300 ohm termination. So it'll give you a slight difference in amplitude. It's really not that big of a deal. But if you want super accuracy, if you're doing signal to noise and things like that, and you want as accurate of a signal level as possible, you need to match the impedance. And that's what this does. This is just a little L network. And I've done a video on how to make this, I believe. And I can take it apart real quick. Hold on. And this is all it is. It's just a coil and a capacitor. And it is very accurately tuned, okay? And it is pretty wideband, but it works. This one is centered on 98 megahertz. So that's about the center of the FM broadcast band over here. And so you can connect your 50 ohm signal generator and you can come out to your 75 ohm receiver. And the amplitude will be perfectly matched. And like I said, this will go from pretty good from 88 to 108 megahertz. And it's most accurate at 98 megahertz. Although across the whole band, it's pretty close. It's close enough that it'll be good for alignments. So you've seen me use this in the past. The Sencor SG80, it has a 75 ohm impedance. It's designed for, audio receivers and so forth, instead of like ham radio and, commercial radio receivers that are 50 ohm. So I don't need this for that, but if I'm using the 8657 and I need a really accurate amplitude, I will use this, although it's not necessary most of the time. This last thing, well, your guess is as good as mine. I forget what this thing is, to be honest. I remember building it, and I remember these two marks are significant to two different settings that I had. It is a 10K potentiometer in series with a 68K resistor. You can see right here. It has an RCA input and then has the banana plug outputs. And I can't remember what I used it for. It was for a very specific purpose. And I only used it for one or two projects, and I can't remember why I needed it. It was to match something, and I don't remember what. I had to attenuate something, and there was this very specific amount. But that's what this is. Nothing special, but just a couple of resistors, I guess. And that's it. That is the Gadget basket. So there you go. A little update on the bench and just a couple of gadgets that going down memory lane there. See what they are. And one last thing that I'm trying, and I've been using these for about 3 or 4 months now. I bought these online. These are little lithium-ion rechargeable 9-volt batteries. And they don't really put out a solid 9 volts. They put out more in the 8 volt, 8.5 volt range, which is fine. But what I purchased them for is I'm running my meters and anything on the bench that uses 9 volt batteries. I'm using these. It came with this nice little charger up here that charges up to 4 of them at a time. You kind of plug them in up here. And so far, I've been using these, like this meter has one in it. The nice thing is they don't leak like an alkaline battery will leak. And you can recharge them, and they charge relatively quickly, and they last a really long time in between charges so far, especially on low current draw stuff like these meters. So I'll let you know later on how they work out, but up until this point, working really well. So that's it for now. we will try to get some more things on the bench. I have a quadraphonic system I want to get on my bench. I did not do a video of the SX980, the tuner alignment, because quite frankly it didn't need aligned. It was just spot on perfect. It really didn't need anything. AM and FM are both working. The stereo separation was perfect. There's really nothing to show on that one. So we'll have plenty of opportunities to do some more tuner videos, but for now that one is good. I have a really unique preamp that I need to get done. I have some vacuum tube projects that I want to do. I have a Marshall guitar amplifier that I want to get on my bench and redo, that belonged to one of my best friends, and when he moved away he couldn't take it with him. He was a guitar player for many years and wanted me to have it, and I was very honored to accept it. It's not it's a solid state one, so it's not a real high dollar one, but still it's the sentimental meaning. I'm going to fix it up. And a few things like that. So we have plenty of projects coming up. I have a whole rack system of SAE gear from the 70s that my brother-in-law owned. I'm probably going to rebuild those, and probably there are more things coming in. So the ICO signal generator, so lots and lots of stuff. So for now, I wish you all peace, joy, happiness, and good health in your lives. We'll be back real soon, and the next couple of weeks is going to be busy for me for work, but I will try to get something like this out next week as well, if you liked it. And if there's anything you want to see a little bit more of, let me know. Maybe we'll see if we can do a little more detail on that, and that might be a good video. Thank you all to all of my patrons, and thank you to all of my viewers. You're all special to me, and the reason I do this is because of you, and I appreciate all of you. Take care and have a great week. Bye-bye.